All right, welcome back, everybody. Today we are going to be working with sixth grade math and specifically with expressions and equations, which sounds familiar to me because I think one of the first videos I did, because I'm doing this alphabetical if you haven't noticed, okay, um, was called algebraic expressions and equations. So, it sounds very similar. So let's see what it is, right? You can take a look at that video and then see, and compare, right? Because now I'm trying to think, as a state exam comes nearby, there's two quizzes that sound very similar. So odds are these questions are going to be pretty important. Okay, so let's see what the difference is, if any. Because the main keyword was algebraic. That's what's missing on this one. So let's see, as a reminder, expressions are basically terms that are combined, right, with pluses or minuses. Equations is the same thing. You're going to have something plus or minus something, but what makes it special is you better put an equal sign. Okay? So that's the main thing. And that's what I went over in that video, right? If they ask you for an equation, you better put an equal sign. If you don't put an equal sign, you are automatically wrong. So that's a ginormous clue that the state exam will give us, right, in our test. So just keep that in mind. All right, so let's get into it. Let's see how they want us to deal with this. Enter the value of R that makes the equation below true. Oh my God, they want us to solve an equation. Now here's the kicker, right? Like I taught 7th and 8th grade math, just as a little background, in California, okay? So I did Common Core, right? That's what I was, stuck with. I was not teaching before Common Core, so that's what I knew, this state exam. So 6th grade, I don't remember, don't fault me if you learned how to solve equations properly. But like I showed my 7th and 8th graders and even the high school kids I teach now, you technically have been solving equations since elementary school. Let me show you, right? Right, that's like, remember elementary school? You had this. 10 plus a circle equals 15. What's the circle? Or they had 5 plus a star equals 8. What's the star? And then you had like a bunch of clues and blah, blah, blah. Remember those? See, if I'm drawing back memories, you've been solving equations since like elementary school, guys. Okay? It's the same idea. So in this case, let's just see if you're good at your multiplication tables. So 4 times what equals 48? So let's see how good you are in multiplication tables. And if you're not, that's okay. What I used to love to do is my multiples, because most of us, including myself as a student, memorized our multiples in order. So what I mean by that, it's 4, then there's 8, because all you're doing is adding another 4. So 8 plus 4 is 12, and then there's 16, then there's 20, and guess what number I have to get to? I have to get to number 48. So that's okay, I can keep going. So 4, 8, 12, 16, 20, 24. Another 4 is 28. And then I'm using my fingers. You can't see me. So 20, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48. So what did I multiply that 4 by to get to the 18? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And again, those of you who are like, why are you teaching me this? Like, this is boring. Like, how? Like, duh. Just remember, there's different ways to get the answer. For some of us, it'll be a lot easier. It looks like a lot of work, but for some of us, it's a lot faster to write out these multiples than to try to imagine our multiplication tables in our head, right? I always tell that to kids. It's easier just to write down the pattern. It seems like a lot of work, but if you notice, it took me less than 30 seconds. Okay, for most of you, it'll take you less than a minute, and you won't have a headache. Just trust me on that, okay? It's a great strategy for these, okay? All right, so let's see. Next one, look at the inequality. Let's see, the inequalities below. So It's talking about that symbol right there. Determine whether each value of x will make the inequality true. Select true or false for each value. So let's do a little recap for today, just in case I see it again. So if it looks like this or like that, this is less than. This one is greater than. If it has a line underneath, is basically the same thing. So it's less than. However, I'm going to have or equal to. So the little line means equals. Okay? So then this one is greater than or equal to. So what's another way to read this? And honestly, guys, as I teach high school, I still got to teach it to the kids this way. Okay? It's easier to remember because our elementary school teachers probably across the country or the world probably did the same thing, right? Like mine did, where the alligator eats the bigger number, or the shark eats the bigger number, or whatever animal. I don't know what they told you, right? And if you're like, what the heck are you talking about? So in this case, I'm going to do this bigger. The alligator ate the bigger number. So in other words, the x has to be bigger than 6. But here's the kicker. I also have that. So it can't just be bigger. It can be bigger or equal to 6. So that's how we're going to read this, right? So if I put in a number, which one of those will work out? The last thing I'm going to tell you is the number line. I had this on one of my other videos earlier. So 1, 2, 3, 4, 5. -1, -2, -3, -4, -5. So your number line is super important with inequalities. And again, at the beginning of the videos, I always take longer because I have to set up the whole quiz probably. Okay, then I go faster because you can always go back to this. Okay. So the right side are pluses, they're positives. The left side of the 0 are negatives. What you're going to notice is, or you should hopefully understand by now, is as I go to the right, what happens to my values? The value increases. In other words, the number on the right is always greater. Okay? Just keep that in mind. So I'm going to have, let's see, I wanted to -20. Okay, so let's see. Let's do one at a time. So let's start with -6. My original one was 6 less than or equal to -6. Is -6 bigger or equal? So means we're like, yeah, Beltran, it's equal because they're both 6. No. Because one of them, let me see if I could do it here. Where is it? Oh, there's my picture. Let's go to collections. Let's go to math. And please tell me I have a number line. Is it this one? Let's hope it's that one. Yes, it's right there. Okay, awesome. I'm going to put that down there. All right, sorry for that. I just wanted to make sure I had it. Now it makes it a lot easier to see it. Okay, so what are my two numbers here? I had 6, so there's my 6, and I have a -6. Is a -6 bigger? No, the one on the right is bigger. So is that true? Nope, that's false. Let's do the next one. I have 6 less than or equal to, and again, your x is 2. So now, let's clean that up. I have a 2, and I have a 6. Is the 2 bigger than the 6? No. Okay, the 2 is not bigger. The 6 is bigger. Okay, let's do the next one. 6 less than or equal to 6. So 6 and 6, are they the same? Yes. All right, next one. I got, let's see, 6 less than or equal to negative 10. So there's my 6. I should leave the 6, huh? So that one I'm going to leave in black because that one is always there. Right? I don't know why I keep switching it. So let's see. Where's the negative 10? The negative 10 is over here. Is negative 10 bigger? No. And then the last one, what do we have? 6 less than or equal to 25. Is the 25 over here somewhere bigger? Yes. So here is another strategy, right? The select all. Notice there was 2 and 3 that were picked. It is going to be super, super, super rare, guys, to pick all true or to pick all false. Okay? It is super ridiculously rare. So it's always going to be a mixture. Okay? So it could have been 1 and 4, it could have been 2 and 3, it could have been 3 and 2, but it's not going to be all 5 true or all 5 false. Just a heads up. Okay. So there's that. I'm going to go a little quicker when we get to these now, okay? All right, simplify and enter the value. Hey, this one is like your algebraic expressions and equations. It's the same thing. But there, they told me to enter the value. It's the same thing. So if we did that one, or if you saw that video, we did order of operations. And in order of operations, I do not like to use PEMDAS. Let me explain what I'm talking about. PEMDAS gives us the illusion that you're going to do everything in this exact order. You are going from left to right because this is America. This is how we read. The reason I don't like PEMDAS is because some of you guys are going to multiply before you divide. And really, it's multiplication or division, whichever comes first, left to right. And then it's addition or subtraction, whichever comes first, left to right. So technically, I could have said PED and switch those two. Or I could have said PEM and then switch those two. That's why I don't use PEMDAS, okay? Because it tricks some of us, all right? I'm going to do it in this order. Yes, if you want to say PEMDAS to kind of remember, but again, I'm going to stick to that strategy when we're simplifying expressions like this. Just a heads up, okay? All right, so let's do one at a time. So let's see, is there parentheses? Yes, so there's my parentheses. Everything else stays the same, 36 divided by, and what did I get in my parentheses? 9 minus 6 is 3, and there's a times 2. So parentheses, check. Is there an exponent? No, there's no exponent. Is there multiplication? Here's what I said, right? Yes, there is. But which one comes first? Division. So I'm going to divide that first. So 36 divided by 3 is going to give me 12. And then I'm going to multiply that 12 times 2. So then what's my next one? Is there multiplication? Yes, there is. So 12 times 2 equals 24. All right. And this is where it's a little weird because I guarantee you, some of you guys are like, well, I got the same thing if I did it the other way. Yes, but it doesn't always work out. Okay, sometimes it does. Sometimes it doesn't. All right. So you got to remember it's multiplication or division, whichever comes first. Because if you had done it this way, and again, you don't have to copy this, I would have said 36 divided by 3 times 2. And you would have said, oh, multiplication, that's 6. And then division, 36 divided by 6 is 6. This one is wrong. Okay? It's multiplication or division. So just be aware. I know I'm being annoying with it, but it gets a lot of you guys to get it wrong, right? And even though you're doing everything so awesome, it's just the order. The order matters. All right, next one. Enter the value of S. So again, there's your little star. Okay, that makes the equation below true. Let's think about this. And again, love my Common Core way of thinking here. So I don't have a calculator. I can't use a calculator. So technically what I need is I need a value of S that makes the equation true. What I notice with my equations is that my partial number, my fraction, right, of this mixed number, has a denominator of 7. So the question is, how did I get from 4 to 6? Well, I had to add 2. And in order to get these the same, because the denominator is the same, then I'm going to say, oh, this one is 2 over 7, because 2 over 7 plus 4 over 7 equals 6 over 7. So here's my first one. Then I'm going to split this and be like, all right, well, how did I get 12? Well, how did I get from 4 to 12? Well, in this case, I just simply had to add 8. So then I can say 8 plus 4 equals 12. So if I have this as my number, I can enter the value and say, oh, my answer is 8 and 2/7. And again, on your keyboard, and I'm going to show you, I know you can't use this, but it's very similar. On your keyboard, you will be able to write something like 8, and then you will have a fraction button. Do you see that fraction button here? That A over B, where you can put the 2 and you can put the 7. So you got to get used to it, right? Well, I saw some calculators down here, so maybe we'll see it. But yeah, we got to get used to that Desmos calculator. All right. Next one. Choose all the number sets that will make the given inequality true. So here it is again. I'm going to use this. I'm going to copy this. Copy. Let's see. Can I paste it over here? Paste. Yeah. All right. All right. So x is less than -5. So in this case, I have -5 there. Nope, that's +5. X is -5. And what I want you to know is that this one is smaller. Why? Because again, the alligator eats the bigger value. So remember what I said earlier. The number on the right is always bigger. So that means that the 5 has to be on the right because it's the bigger number, okay? So let's look at the other options. -5, -4, -3. Were those on the left side of the 5? No. So it can't be that one. Let's look at the next option. -10, 10, and 20. So the 5 worked out for this one, but it didn't work out for those. Okay, so this one also doesn't work. So let's go to the next one. -6, -7, -8. Is the -5 on the right side? Yes. So that one works out. And the last one, let's see, let's do the yellowish orange. I got -10, -20, and -30. Is the -5 bigger? Yes, the -5 is on the right side. So this one, again, is 2 out of the 4 choices. And as we talk about strategy, right, when we say select all, are you going to pick 1, 2, 3, or 4? You're not going to pick 1. If you're going to pick 1, that's multiple choice, right? And it is super, super rare to pick 4. So in this case, you're going to pick 2 or 3. It's a test-taking strategy, guys. This is like 99.9% of the time. All right? It is super rare to just pick one of the select all. questions or pick all of them. Back in the day when I was your age, give you that speech, we used to have that. Select all of the above, right? The teachers listening to this will remember how annoying those questions were. Okay, yeah, they got rid of those for you. Okay. All right, choose all the expressions. Otra vez. So how many do I have? I have 4. So I'm not going to pick 1. I'm going to pick 2 or 3. So choose all expressions equivalent to that one. So what do we know about parentheses? Well, I know when I tell my kids what does parentheses means in high school, most of them remember, oh, parentheses means multiply. So let me show you a visual. If I give you something like this, do you know what I'm talking about? And hopefully by now you realize, oh yeah, if there's a parentheses, that means it's 2 times 3. The issue is here, oh yeah, my parentheses doesn't look like that. My parentheses is big. So in this case, I'm going to say 2 times that term, 2 times that term, and 2 times that term. And what do we call this? We call this the distributive property. So 2 times 3 will give me 6, and there's an X there. 2 times -4 is -8 with the Y. And then 2 times +5 is +10 and it has an X. So what I recommend you do, right, is just simplify everything. They give you a lot of these questions in the state exam at all grade levels, by the way. They want you to compare, oh, what does this turn out to be? And if you simplify everything when it comes to expressions, you will always get the same answer at the end. The reason it's annoying is because some of us do things a little different, okay? So for example, some of you guys are going to move around the X's so that they're close to each other and put the Y at the end. Some of you guys might put the Y at the beginning and the X's at the end. And the computer, whoever made this problem, might do it differently than you, even though you got the same answer, okay? So when you simplify everything, it makes things, well, simpler, okay? So now what do we do? What do I keep talking about? I keep talking about simplifying the expression, which means combining like terms. So in other words, X's with X's and units with units. See, that's a habit of mine. In this case, in case you didn't know, units are just numbers with no letters. This case, I have a Y. So X's with X's and Y's with Y's. And because most of you guys are using just a pencil or a pen or one color, that's how I like to do it as a student. I will make my like terms underline and then the other one squiggly lines. And if I run out of there, I'll make like circles or boxes or triangles to keep them the same. Okay. So now what do? 6 plus 10 gives me 16x. And then the y, well, the -8 is by itself, so I'm going to leave it like that. Now let's check. Do any of my answers look like this? Do I have a 16x? Yes, I do. Do I have a -8y? Yes, I do. Guess what? That one is correct. And did you guys notice just a little, like, strategy you can figure out here? Did you guys see that these two and these two look similar? So can you guess if the second half I got 1 out of those 2? Can you guess what the first 2 I want to pick? Probably 1 out of 2, no? Most likely. Do you see, like, test-taking strategies, guys? It's a visual thing now, okay? So how do I figure out which one it is? Well, again, I want to simplify everything. It's a little bit of extra work, but I always tell students, it'll be faster in the long run because you guys can do this stuff a lot faster writing it on paper than trying to fix everything in your head. So what do I mean by that? It's combined like terms. X's with X's, Y's with Y's. 5 plus 7 gives me 12X's, and then I have a -2Y. Is that the same as my answer? No, that one does not work. Let's do the next one. X's with X's, Y's with Y's. So 6 plus 10 is 16X minus 8Y. Is that the same? Yes. So that one works. Then I do the last one. I got 10X minus 2Y. Are those the same? No. So, do you see what I mean by just simplifying every single thing? And I'm going to do this in all 7th, 6th, 7th, 8th high school. It's the same strategy. Okay? It looks like you're doing a lot more work, but honestly, really, you just added, right? Like, it's not horrible. And you could see it a lot faster. Okay? All right. Next one. Same idea right here. So let's see. Choose all expressions equivalent to. And I got 4, so I'm going to pick 2 or 3. So let's see. Combine like terms. So T, that has a T, and that has a T. Then that's a unit. That's a unit. If you remember what I just said earlier, units are just numbers with no letters. So let's look at this. I got 2 plus 6 is 8. 8 plus 4 is 12T. Then I have a 4 plus 5, which is 9. So which one of these is going to equal 12T plus 9? Hey, look, I just got one of them. Is this 23T squared? Yeah, nah, I don't know where they got that from. And you're like, okay, those don't look like it, so why did they try to do stuff? Like, what are they doing? And if you're trying to figure it out, a lot of you guys aren't realizing that they're factoring out stuff. But what a lot of you guys, I think most of you guys, like 90-something% of you guys will see is that parentheses just means multiply, right? This is why it makes it easier. Look, I know that I have to do this, right? And anytime you see your little arrows, hopefully you realize, oh, I have to multiply 3 times 4. That's 12T. And I have to multiply 3 times 3. That's 9. For the other one, same idea. 6 times 6, which is 36T. And 6 times 3, which is 18. Which one of those gave me 12T plus 9? So you're going to notice, hey, look, that one's the same, and that one is different. So did I do a little bit of extra work? Yes, but I didn't have to overthink it. And that's what I want you guys to realize when you're taking these tests, especially for these types of problems where they want you to be like, compare, right? Compare. And they're supposed to give you the same answer at the end. It's just easier to do the work. Okay, by that I mean simplify. Always simplify. All right, number 8. Okay, now this is looking very, very similar. So let's see. Does it still remember that I have a number line? Yes, it does. Okay. So let's erase those. In this case, I want x is less than 1. So there's my 1. And because the alligator ate the bigger one, this one has to be on the right. Okay, so let's do one at a time. 6 over 4. Where is 6 over 4? Yikes. Well, let's see. If I do 6 divided by 4, that gives me 1.5. Right? And you're like, if you're a little lost, okay, let's do some strategies here. If I do 4 over 4, that equals 1. If I do 8 over 4, that equals 2. So because I have a 6 over 4, that's in between, so that's 1/2. So there's the 1/2 right there. Is that correct? No, the 1 has to be on the right, so that is false. Okay. All right. And think about it. 1.5 is 1.5 less than 1. No. Right? 12 over 13. So the little trick to fractions, right? If the number is smaller than the denominator, then it is less than 1. If the number is bigger than the denominator, then it is more than 1. Okay? So this one's 12 over 13. Well, 12 over 13 is less than 1, so it's somewhere down here. So yeah, this one is true. 12 over 13 is less than 1. Next one, negative 2/3. Is that less than 1? Well, my negative numbers, and again, I'm looking at the 1 here, right? My 1 is my answer that I'm comparing everything to. If I have a negative 2/3, well, it's somewhere over here. So is that smaller? Yeah, it is. Okay. So that one is true. Negative 2/3 is smaller than 1. And what's my last one? Oh, I got 2 more. 5/19. So 5/19, that 5 is smaller than 19. So that means that 5/19 is in fact less than 1. And 9/2. 9/2, is that less than 1? Where the numerator is bigger than the denominator. So that one is false. And what did I say earlier? It is rare for you to pick all true or all false. It should be a mix. Okay. So this one had 3 correct. This one had 2. It is going to be rare if it's all true or all false. All right. So got a few more, and I'm starting to see calculators eventually. So that's kind of nice. And let's see, I got another one right here. So let's do more number lines. So let's see if you got in the hang of it. So I got a 6. So there's my 6. And it says that x has to be bigger than 6. Has to be bigger or equal to 6. So that means your x's has to be on the right side. So let's see what your x's are. So my x's are going to be 6, 7, or 8. Does that work? Yes. Let's do the next one. Let's do 6, 5, and 4. 6, 5, and 4. No, 4 is not bigger than 6. Because again, you're doing 4 bigger than or equal to 6. Yeah, that does not work. So that didn't work. That didn't work. Okay. So let's go to the next one. -6, -7, -8. Is that bigger than 6? All those negative numbers. No, those do not work either. And then the last ones are going to be 10, 9, and 8. Is 10 bigger than 6? Is 9 bigger than 6? Is 8 bigger than 6? Yes, they are. So this one I picked 2 out of the 4. All right, getting closer to the end, and notice the strategy here. Like they like to give you the calculator and stuff at the end. Okay. So Martin is making horchata. Okay, so that's like, it's like a rice milk kind of thing. Those of you who didn't know. For his class potluck, the recipe calls for 5 cups of milk, 2 cups of rice, and 1 cup of evaporated milk. So enter the percentage of the horchata recipe that is rice. So let's see. What do I have here? I have 5 cups of milk. Then I have 2 cups of rice, and I have 1 cup of evaporated milk. Okay. So how many total cups is that? That's a total of 5 plus 2 plus 1. That's a total of 8 cups. But here's the thing. I only want rice. So if you got a percentage is what you want over your total. So in this case, I want rice over my total. And my rice was 2 cups over my total of 8 cups. And they gave me a calculator. So I'm going to bust out my Desmos calculator. There we go. Clear that. So let's see what I have. I have a fraction button. There it is. I got a 2. Then I go down here, put an 8. And it says enter the percentage. 2 over 8 equals 0.25. How do I make that into a percent? Well, let's play around with this. If I put a percent, does that help me? No, it doesn't. So 0.25. Can I do the percent of? No. So that didn't help me for these buttons. Okay. So what do I do to figure out the percent? You got to move the decimal place twice to the right. So this one is going to give me 25%. So again, to go from decimal to percent, you move the decimal 2 places to the right. Or multiply by 100. That's the easiest thing to do, to be honest. Okay, because I always forget is it to the left or the right. So if I have 0.25 and I multiply times 100, I get 25. That's 25%. All right, next one. Mr. Bertrand's wife, and I'm going to keep my calculator open because it has a little picture of it. Mr. Bertrand's wife likes to go on walks with her parents at the local school track. Let D represent the number of days they go to the track. Let S represent the total laps completed. So let's see. This looks like one of the other quizzes where we had like a bunch of tables. Okay, so here it is again. So enter the total number of laps they walked after going for 8 days. So let's see, do we see a pattern here? So let's find all the patterns that we can on this table. I found one pattern going this way. 1, 2, 3, 4. Pretty simple, right? So notice all that happened here is I added 1. I added 1. I added 1, and I got to my next number. This one, though, what happened? How did I get from 8 to 16? Well, I multiplied by 2. But 16 to 24, did I multiply by 2? No, that does not work, so I can't say that. But everything's adding on the other side, so 8 plus what is 16? 8 plus 8. Does it work for everything? Well, let's check our calculator. I got 8 plus 8 equals 16. So if I have 16 plus 8, that equals 24. Oh, yeah. If I do 24 plus 8, not minus, sorry. That gives me 32. So there's my pattern. So what do I have to do? I have to go all the way to 8 days. So I'm just going to make another table here where I can continue it. And there's 4, 5, 6, 7, 8. So the 32, I can just keep going. So 32 plus 8. So 32 plus 8 equals 40. Boom. 40 plus, nope. 40 plus 8 equals 48. 48 plus 8 equals 56. And 56 plus 8 equals 64. So after 8 days, they will walk a total of 64 laps. Wow. Okay. Now, the other way you could have figured it out, and I like to teach you multiple ways just in case you didn't see it this way, is, and again, if you've taken the other quiz, you're going to see where I'm coming with this, is I went vertically. Is there a pattern going across? Because for some of you, you realize this way before, and you're like, Beltran, why are you still doing that? Well, let's see. How do I get from 1 to 8? The first thing I like to do is add. So 1 plus 7 equals 8. Well, I got to do it to everything. So does it work with 2? 2 plus 7. Yeah, that didn't work. So the other way to get bigger, right, from 1 to 8, it got bigger. I can't subtract. I can't divide. So my only other option is say 1 times 8. So if I do times 8, that equals 8. Does that work for everything? Let's check. 2 times 8. Yeah, that's 16. 3 times 8. Is that 24? Let's check. 3 times 8 is 24. Yeah. Then 4 times 8 is 32. So those work out. So instead of doing plus 8 plus 8 plus 8, I could have just said 8 times 8 equals 64. So again, 2 different ways to do it. And you're going to see if you've already done the other quiz, right? Very similar style of problems, okay? All right, so I got a few left, and then hopefully we're done. Only up to 16. Yes. Okay, and the next one's geometry. All right. Georgia has a bag of Skittles, yum, that she opens during lunch. She eats 12 Skittles. Okay, numbers are important, so I always circle my numbers. So 12 Skittles at lunchtime. After dinner, she treats herself to X. I also circle letters or variables. So X more Skittles. What do you think more is? Adding, subtracting, multiplying, or dividing. In this quiz, you had to add more Skittles. Enter an equation. Here's what I was talking about earlier. It told me to write an equation. That means you better have an equal sign in there. Okay? That represents the total number of Skittles. There's another letter that Georgia ate. So what do I have? What did I just circle? I have a 12. I had a letter X. I have a plus. I have an equal sign because it's an equation, and I have a Y. So let's see if I can kind of piece this together going just in order. So Georgia started with 12. Then she had dinner, and after dinner, she added X amounts. Enter the equation that represents the total. So if I have 12 plus X, that gives me a total of Y, a total of her Skittles. So let's check if I used everything. Did I use a 12? Yes. Did I use the X? Yes. Did I use a plus? Yes. Did I use an equal sign? Yes. Did I use a Y? Yes. This is important as a skill, guys, because when you label everything that you need or that you see, okay, 95% of the time, unless they want to trick you, but it's rare, okay, so just be careful. But 95% of the time, I think, or 90%, they will kind of give you all the information there. You just got to pick it up, okay? So then my equation, I'm just going to put 12 plus X equals Y. Okay, so let's say some of you guys did not write it in this order. The good thing about the state exam is they will basically okay any equivalent equation, okay? So what I mean by that is some of you guys might have said, you know what, Beltran, I actually put Y equals X plus 12. Well, guess what? That is totally okay. It's the same thing, okay? It's the same setup. It's going to give you the same value. It's going to be the same everything, okay? You just switch things around. But it is an equivalent equation, so they will accept it, okay? The key thing is, did you fill in everything they wanted you to? All right. All right. So let's move on to the next one. A few more to go. So Genesis, Brianna, Emily, and Rebecca are asked to write an expression equivalent, so equivalent to 2x or 2 parentheses 3x plus 4y close parentheses. So Genesis wrote that, Brianna writes that, Emily writes that, Rebecca writes that. Who is correct? Okay, so here's the nice thing about this. We are playing teacher. And I love these types of questions, right? Because your job is to find the mistake, if there is any. And here's the thing is, who is correct? That means one person for sure is correct. And the thing that's nice about it is I'm looking over, again, test-taking strategies, guys, is I'm looking and they gave me the final answers, right? And I love that as a question because if I'm looking at this, I just got to work it myself and match whoever got the answer that I got. The ones that stink, and this is for those of you who get a similar question on your exam, but just a little different, what they like to do is they'll be like, oh, these persons got like the same answer, but this person did it this way, and this person did it the other way. And usually what happens is one of them got lucky, okay? So, yeah, just those are usually the couple different ways that, you know, they give you the teacher questions. So let's just, like I said, let's just do it our way because we know or we assume that we're going to do it correctly. So I'm going to start with the 2 parentheses 3x plus 4y. And to me, when I see parentheses, my brain automatically says, oh, I got to multiply. In this case, because there's more than one term in the parentheses, I'm going to distribute. So I'm going to multiply the 2 times 3x, which is 6x. And I'm going to multiply the 2 times 4y, which is 8y. So in this case, who got it right? Boom, right there. Brianna writes it correctly. And there's only one option for Brianna, which means it's B. I don't even care what the rest says because I know that's correct. Okay? All right, so that was 13. Let's go to 14 and then 15 and then 16. Oh, okay, we're almost there. Almost there. If you buy a bag of trail mix from the store and discover, you buy a bag of trail mix from the store and discover that there are 3 times, okay, there's a 3, times means multiply, as many raisins, I have an R, as peanuts, and I have a P. Enter an equation, so you better have an equal sign that represents the total number of raisins, R. Okay, so let's see. What do I have? I have a 3. I am going to multiply a 3. That's different than an X, okay? I have an R, I have a P, and I have an equal sign. So I have 3 times, I'm going to go in order. I have 3 times as many raisins as peanuts. And this is where it gets so confusing, right? Because is it 3 times R or is it 3 times P? So I'm going to read that again, okay? Because that's usually where we screw up. It's like a 50-50, right? Because the only thing left over is equals and then the other letter. Okay, so if I have 3 times as many raisins as peanuts, that means I have more raisins. So if I put in a number, right, and I say 3 times R equals P, or 3P equals R, let's just plug in a number. If I plug in 10, I love 10. Okay, so 10 for R. So 3 times 10, and that gives me 30. So if I use this equation, I had 10 raisins and I had 30 peanuts. Which one's supposed to have more? I'm supposed to have more raisins. So if I do it over here, I'm going to say 3, and then my P I don't know, and my R is 10. Well, 3 times what equals 10? Well, this one, if you didn't, well, we have a calculator. So actually, let me split this open. What you guys will discover is, how do I get there? It's basically 3 1/3, okay? So 10 divided by 3, so 3.333333. So again, is my raisins bigger? Yes. So my equation in this case is going to be that one. So I'm going to have 3P equals R. Now, if you put R equals 3P, that is totally okay. All right, it's the same thing. All right, last 2. Jonathan has a weekend job where he mows the lawn around the neighborhood and earns money. Nice. Let L represents the number of lawns. So there's my L right here. And M represents the money. Yeah, right there that they earned. So let's see. Enter the total number of money Jonathan earns after mowing 6 lawns. So where's the 6 at? So in this case, if you look at it, there's my L, and I'm supposed to have, there's 4 1/2, 5 1/2, and then 6. So notice I skip one, right? So 4 and then 5. 5 and then 6. Okay. So how do I use this to help me? Well, it looks like I have 1 lawn cost, what number is that? What's in between 20 and 40? Well, that one is going to be 30. So if 1 lawn equals $30, how much does 6 lawns equal? Well, think about it. I just had to say, oh, I have to multiply this times 6, no? Because it's 6 lawns. Every lawn is $30. So I'm going to say 6 lawns times 30, and that equals $180. Just double check here. 30 times 6, yep. Or 6 times 30, and I get the same thing. All right. Next one. Mr. Beltran's class average for the last test was 60 points. Okay, I see a number, so I'm going to circle it. Mr. Beltran predicts that the next test average will change. So that means it's going to add or subtract. They didn't tell me. So is it a plus or a minus? By exactly 20%. Choose all the correct averages if the prediction is true. Interesting. Okay, so there's no equation, right? There's no equal sign. Notice there's check boxes. So I'm going to pick 2 or 3. I can't pick 1 because it's not multiple choice. And again, super rare to pick all 4. All right. So what do you guys think I should do here? Well, if I know that my average was 60 points and it's going to change by 20%, I need to find out what 20% of 60 is. So if I look at my calculator, look, I just pressed the percent button. Well, I want 20% of 60, and I got 12. So how did they do that, right? Like, what if yours doesn't look like this, even though it's a decimals one? Well, think about what this means. I want to find 20%. There's my percent. And notice, of 60, well, I could have said 20%. And this one won't even let me. Times 60. That's technically what I'm doing. I'm doing 20% times 60. And depending, because this is a decimal, so I'm assuming it's going to be the same thing for you. It's technically multiplying. That's all it's doing. So you're multiplying 20% times 60, and you get 12. So here's the thing. It's going to change. It didn't tell you if it's going to be bigger or smaller. And notice you have to pick 2 or 3. So it's going to change by 12. So if I have 60, if I add 12 to it, I get 72. So that one is 60 plus 12. But if I go the other way and I subtract 12, I'm going to get 48. Those are my answers. The key thing you're going to notice is they said points. That's your clue. What some of you guys will do, and this is wrong, okay, is you're going to say, oh, I had 60 and I subtracted 20. But think about what this is. Points and percent. Are they the same thing? That's a little clue for you guys. Again, test-taking strategies. Because they're going to trick you, right? If you said 60 minus 20, guess what that equals? That equals 40. Hey, I got 40 points. But you cannot subtract points from percents. They are not the same. That's like trying to combine an X with a Y. They are different. So hint, hint right there, okay? And guess what the 80 is, right? 60 plus 20 gives you 80. You can't do those. They are different. So there you go. That was it. Hopefully I cleared up a couple of things for you guys. And I will see you next time.